Hey everybody, it's Mr. Zabo. We are going to continue with LT20 using some video notes. We're going to do a couple of practice problems today and kind of get you guys through your notes. So we should be on page 4 of our notes. We will skip page 3 for now and come back to that. And here on page 4, we're going to talk now about multiplying binomial times a binomial. And on our notes here, we've got the section here for you guys to kind of see what you notice and make a prediction as to how this happens. So if you guys don't mind, maybe press pause and write down something that you notice and some kind of a prediction that you might have as to how we get from binomial times binomial and wind up with this trinomial in the end. So hopefully you had a chance to make a prediction here, but there's two different methods that we're going to talk about and make recommendations on how you show your work here. The first one is the distributive property. Yesterday we talked about the distributive property with a monomial times any size polynomial. With a binomial times a binomial, the key is you are going to take anything in this first set of parentheses, in this case 2x minus 3, and separately distribute to the second set of parentheses. So for example, we have 2x minus 3, or 2x times the x, and we have 2x times the 5. Okay? The x plus 5 was that addition problem, so we write it this way. And then completely separately, I'm going to multiply my negative 3 and distribute that into the second binomial. So this is how we kind of showed it in class. We had the x and the plus 5. Okay? And I took the negative 3 times the x and the negative 3 times the 5. And we showed how we were distributing the 2x and then separately distributing the negative 3. Now I have a series of 4 different monomial expressions that I have to simplify. Focusing here, I have 2 times x times x. 2, and then don't forget this x has an exponent of 1, this x has an exponent of 1. So we have 2, keep the base, add the exponents. I'm going to follow through and do the same thing with each term here. Now I have a positive 2 times a positive 5 is going to get me a positive 10, and I can't lose the x, but I only have that one x to the first. When I'm multiplying this term, I just have a 1 times a negative 3 gets me a minus 3, and I still have just the x. In my last term, a positive 5 times a negative 3 gets me a negative 15. Just like yesterday, we do always have to look to see that we have like terms, and we have to simplify those, and we have to put this into standard form. 10x and negative 3x are my like terms. 2x squared, positive 10 and a negative 3 is a positive 7x, and minus 15. Scrolling back up, that's the exact answer we had up here. And you can see the middle step, how we got there. This was distributing my 2x. This was distributing my negative 3. A more approachable way, I should say, for doing this, and a way that might make sense for some of you, is to actually look at this kind of like a Punnett square. So a lot of you have done these Punnett squares in your science classes. What we want to do here, and again, if I look at this, one of the keys in this learning target is looking right here in between my parentheses. In LT19, we talked about the sign that was in the middle here. We would have an addition sign, a subtraction sign. No sign implies that we are multiplying. That tells me that I am multiplying here. So one method is to take your first polynomial and take each separate term and write them either vertically here, a positive 2x and a negative 3, or write them horizontally, and take your other ordered pair, a positive x and a positive 5, here. Now, when I am filling in the Punnett square, it's all multiplication. Take x times 2x, and there's my 2x squared. And if it helps to see where that came from, this was my, whoa, don't need it that big. This was the x from the top part of the Punnett square times the 2x from the bottom part of the Punnett square. This is a positive 5 times my 2x. This is an x times negative 3. And this is a 5 times negative 3. 2x squared, there's my 10x, there's my negative 3x, and there's my negative 15. Now you've got to make sure you pick out your like terms. Oftentimes, they're going to be on diagonals. That's not a full rule, but that's oftentimes going to be the case. Those are my like terms. Then in standard form, x squared is the largest exponent term. That gets written first. I combine my like terms. There's my plus 7x still. And I still have my minus 15. Two different methods of getting the same answer. What I'd like to see you guys do is press pause, and using either of the methods above, try that last problem on page 4, please. Right now, I am going to recommend that we focus on the table method. I think a lot of you are going to really relate to this method. And again, just to prove, I put my first binomial across the top and my second binomial across the side. It doesn't matter which one we do, though. Okay? And then we multiply 3x times x, 3x squared. So this is our LT18 skill. We just got to be able to physically see how we're multiplying there. A positive 1 times x is a 1x. A positive 3x times a positive 2 was my positive 6x. A positive 1 times a positive 2 is a positive 2. Notice how I'm including that addition sign. Anything that is positive, it doesn't hurt to write that addition sign in your Punnett square, in your table. And then when you're going to write your simplified answer, making sure that we pick out largest exponent term first. Write that down, 3x squared. Then look for like, oftentimes my like terms are going to be on this diagonal. I do have like terms. I have a positive 6, a positive 1. The positives help me see that I'm adding. I get a positive 7, keep my x. I have a positive 2 as the only term. I'm in standard form. I'm done. Okay, now on the next page, if you look at page 5, there are 3 problems at the top of page 5. I'd like you to try those 3. We are going to stop the notes today before we hit that last example. If you want to try it and see what you guys can come up with, you're welcome to do so. But you're going to press pause, and when you're done with pause, I'm going to unpause it, and the answers and my work will be displayed. I'm not going to walk through each problem, though. Okay, and here's our answer to these three problems with my Punnett squares that'll help us identify our solutions. Please check your work, make corrections, and you can call a teacher over and they can check to see if you're ready to move on to the next part of the lesson.